All right, so we have already set up and established the size of our gauge blocks. We're going to now use our test indicator to come over here. We're going to put the gauge blocks underneath that. I'm going to kind of ring these on the surface plate just to make sure that we're good to go. And then I'm going to use my fine adjustment to come down and touch off. Now, remember, before I do this, remember you want the point of your indicator set where it's pretty much straight out from your test indicator. We don't usually want to set this where they're down here like this or up here like this because we get cosine error there. So we're going to kind of keep that pretty much in line as we go. Now I'm ready to come over here. So let me readjust this just a little bit more, and I'll use the fine indicator or fine adjustment on my height gauge. We'll come in, I'm going to touch this off to 0. Now, notice when I set this, I've already moved my dial so that I'm only moving about 5 thousandths. We could kind of come in here and I could move this all the way where we need to come over, and depending on the range of our test indicator, we could come in and we could do a whole 25 thousandths if we need that type of range. But in this case, I don't need that much range. So I'm just going to kind of keep this limited to about 10 thousandths of tension or pressure on that particular dial. So, or on the tip of that. So there we go. I'm set at 0. I'm coming back in here. I'm going to kind of move my gauge blocks in and out just to make sure that they repeat. So see how they repeat. So all right, so I know now that my size should read at 0 when I test all of these parts. So here's the first one. Let's see if this is undersized or oversized. If it's on size, it's going to read 0. If it's undersized, it will be to the minus of our 0. If it's oversized, it will be to the plus of our 0. So I'm just going to kind of roll this under. There we go. All right, now you can read this. I'm going to find the high point. Notice I'm rolling this under. I don't have to roll it. I could also slide it, but you'll see here we can read that. So take a look, read that indicator face. You'll see we're about 5 thousandths oversized on this part. So now, depending on our tolerance, that may or may not fall in tolerance. So let's check our second one. So again, I'm going to roll this, or you can slide it. All right, we're not a full 5 thousandths on this one. Looks like we're about 4.5 thousandths oversized on this one. So a little bit, just a little bit less, but we're still to the plus on our dimension. So if our tolerance on the print says that that's plus or minus 10, then we're good. Or if it's plus or minus 5, we're good. If it's plus or minus 1 thousandths, well, these parts would have to go back and have that material removed from that outside diameter. So here we go. Yep, and this one comes in just a little bit over 5 thousandths as well. So this is how we use for the test on repeatability. This is how we would use this indicator. Now, if you think about the applications for this, if you are a large-scale manufacturer, think like automotive industry or any type of manufacturing where you've got orders of, say, 1,000, 5,000, 10,000 parts and pieces, you're not going to do and want to sit there and take a micrometer measurement on every single one of these. But maybe you say, well, in our quality control and our process control, we're going to test every 10th piece or every 50th piece or every 100th piece. So those pieces would get pulled and you'd come in and you'd have this type of thing set up where you don't have to physically take the measurement with a micrometer. You can just use this test indicator to prove out you're still on size. Of course, if you're off, then you go back, you make adjustments to the machine to cut to the size that you need. And this is the one way that we would use a indicator to prove out repeatability on a part.